Welcome back to another video on the channel. In today's video we're going to be going over chemistry question 24 of 2020's external exam, paper 1. Now this one here, same with all the questions, I've started splitting them up into individual videos across the channel. That way if you only struggle with a certain type of question, like question 24 for example, you can go watch the video on question 24. The full exam video is still up on YouTube, the link is in the description below. It gives me a bit more variety in terms of like how well I can go into depth on each questions, and also gives you a bit of variety in terms of like what you need help with. If you need a chemistry external exam bundle pack, the link is in the description below. And if you have any questions at all during the video, just comment below or just send me through an email. But otherwise, let's get straight into it. So, question 24. This table shows the effect of temperature on the pH of pure water. So as we can see here, we've just got to look at the general trend overall. Analyze the data to explain whether the self-ionization of water is endothermic or exothermic. Explain your reasoning. So here, what we notice here, as the temperature increases, the pH decreases. So temperature going up, pH going down is a very important thing to notice when we're talking about the self-ionization of water. Now, a lot of people might be wondering, what do you mean self-ionization of water? Hopefully you know this reaction if you're in year 12 for chemistry, but water switches constantly between H2O and OH minus plus H plus. Now, the reason why this is important is specifically this guy here, H plus. pH is negative log 10 of the H plus. The more H plus you have, the lower the pH it's going to be, is because it's more acidic. If you increase the pH, if you increase the H plus, it lowers the pH because it makes it more acidic. That is important in this discussion here because it indirectly is affecting temperature, or temperature is affecting it. So here we've also got to understand what endothermic or exothermic represents. Endothermic means that you need energy to start the reaction. So you need energy as a reactant. Exothermic means energy is a product. Okay? So the reason why that's important with temperature is because temperature and energy can be interchangeable in the equilibrium system. Okay? So here, when they're basically saying as the temperature increases, the pH decreases, what that directly means is if the pH is decreasing, that means the H plus is increasing. So here, we've kind of got a cause and effect going on. In order for this to increase, the equilibrium needs to shift from left to right. And the only way it would do that is if it was endothermic or exothermic. So let's understand this. If the reaction was endothermic, there would be energy as a reactant. Let's see if this works, because we've got to apply Le Chalais' principle. If I were to increase the temperature, that means I'm increasing the energy on this side here. According to Le Chalais' principle, it will shift left to right to produce more of this stuff here to counteract the energy going in. So yes, that works. If it is an endothermic reaction, as energy is a reactant, if you increase the energy, which is increasing the temperature, it will shift left to right to create more H+, which will indirectly lower the pH. So in this case here, the answer would be the reaction is endothermic, and you have to write into reasoning what I just explained there. Words I would use is Le Chalais' principle. So according to Le Chalais' principle, any change done to a system in equilibrium, it will oppose that change. Therefore, as an endothermic reaction, energy is a reactant. Therefore, if you increase the temperature, you're increasing the energy in the system, which means you're increasing by default a reactant. Which means, according to Le Chalais' principle, it will want to oppose that change, meaning it will decrease that, and in turn increase that and increase that, which in turn will decrease the pH because there's more H plus present. That's what I would write there. Now I can't write because I am terrible at spelling, but what I just said there, I would write if I could. Okay? Anyway, now that we know that's that, calculate kW of pure water at 50 degrees. Show you're working. Alrighty, so let's understand how to do this, okay? You do not need to be able to get question A right in order to answer question B, okay? So here, what we do need though is this equation. So I'm just going to, if it allows me, actually I'll just rub this stuff out. If you need any of that information, just rewind the video. I'm just going to take this guy down. Okay, so KW. KW is the product of H plus and OH minus present. Now they're set at 50 degrees. Now on our data sheet, we've been given the KW value at 25 degrees, so you can't use that. What we need to do is look at the table and think, oh, 50 degrees, what's the pH? So at 50 degrees, the pH is 6.36. We could use that to find the H plus, but more importantly, let's understand this, okay? When it hits 50 degrees, it's going to be at equilibrium. You would have an amount here, none of that, none of that. You would then subtract an amount here, add the same amount, then you'd have an equilibrium value here, X and X. Whatever we have here for H plus, we're going to have the exact same amount for the OH minus. That is very important. So if we calculate the pH, well, if we use the pH to calculate the H plus, indirectly we work out the OH minus. Now we know, if I move this guy out the way, we know that pH is negative log 10 of H plus. Rearranging that, you get H plus equals 10 to the negative pH. So H plus is 10 to the negative 6.63. Chuck that into your calculator, it'll give you a decimal value. What I know is though, because it's a 1-to-1 ratio, and because of this at equilibrium, that is also the same amount of OH we're going to have in the system. So here, KW is your H plus at equilibrium, or 50 degrees here, times by your OH at that same moment, which means you're basically timesing this thing, the 10 to the negative 6.63, by itself, aka you're squaring it. We just chuck that into our calculator, so I'll just do that right now, because I don't have it prepared. 10 to the power negative 6.63, and then I want to square, where is it? Alrighty, so we get about 5.49 times 10 to the negative 14. Now here there is a 5 after the 9, so they said 3 significant figures, so 5.50 times 10 negative 15, or negative 14. And that's it. That's how you do question 24 from the Chemistry External Exam 2020 Paper 1. If you have any questions about this one here, leave something in the comments or flick me through an email. If you need a Chemistry External Exam bundle pack, the link is in the description below. And if you generally just want to check out other videos, link to the playlist is in the description below as well. But otherwise, I'll see you in the next video.